There's a moment in every developing storm when the numbers on a forecaster's screen stop being gradual and start moving in one direction, fast, pressure dropping sharply, wind fields expanding. The system is tightening and deepening as it feeds on the contrast between cold air pushing south from the North Atlantic and warm, moist air streaming up from lower latitudes. That moment is what meteorologists call explosive deepening, and it is the moment the atmosphere stops building a weather system and starts building a threat. The next storm bearing down on the United Kingdom is in exactly that phase right now, and the question every person in its path needs to be asking is whether they are ready for what is coming. To understand what is developing this week, you need to understand the atmospheric pattern that the United Kingdom has been locked in for the past month, because this storm does not exist in isolation. It is the latest in a sequence that has made April 2026 one of the most relentlessly unsettled spring periods in recent memory for the British Isles. The 2025 to 2026 storm season has already delivered 3 named storms to the UK before this one. Storm Goretti struck in January, bringing 2 days of damaging winds. Storm Chandra followed later the same month. And then Storm Dave arrived over the Easter weekend in early April, hitting the country hard at precisely the moment millions of families were traveling and trying to enjoy the bank holiday. Storm Dave set a benchmark for what this type of system can do when it crosses the jet stream and deepens rapidly over the UK. The Met Office named it on April 2nd, as forecasts showed increasing confidence in damaging winds and heavy precipitation. Deputy Chief Forecaster Tom Crabtree described the system as forming and rapidly deepening on the Saturday as it approached from the west. By that Saturday afternoon, winds were strengthening significantly with gusts of 60 to 70 miles per hour expected across parts of Scotland and the potential for 80 to 90 miles per hour in exposed coastal locations. Across northern Britain more widely, gusts of 50 to 60 miles per hour were expected as a baseline. An amber warning for wind was issued from 7 p.m. to 3 a.m. for northern England, southern Scotland, and northwest Wales, reflecting a significant escalation in the level of confidence about the severity of the event. The system brought blizzard conditions to higher ground in northern Scotland, with 10 to 20 centimeters of snow accumulating in the hills despite it being early April. At Capel Curig in Snowdonia, a peak gust of 93 miles per hour was recorded, making it the windiest Easter Saturday on record at that site. In Glasgow, some recorded gusts reached 77 miles per hour, one of the strongest readings the city had seen in years for this time of year. The rainfall totals were also significant, with 50 millimeters falling at Glenample and Stirling, and totals above 40 millimeters recorded across Argyll and the Western Highlands. The reason Storm Dave could do all of that so quickly, going from a named storm to a 93 miles per hour gust in the space of roughly 2 days, lies in a process called explosive cyclogenesis. It is one of the most dangerous storm development mechanisms in the meteorological toolkit, and it is the process that characterizes the most damaging of the storms that hit the British Isles each year. A weather bomb, as it is sometimes informally called in the media, is defined by a very specific threshold, a low-pressure system that drops at least 24 millibars of central pressure in 24 hours. That rate of pressure fall is the atmospheric equivalent of a car accelerating from a crawl to motorway speed in seconds. The deeper the central pressure falls, the tighter the pressure gradient between the low and surrounding higher pressure areas, and the tighter the gradient, the faster the winds at the surface. Explosive cyclogenesis is driven by the jet stream, by the sharp temperature contrast between cold polar air and warmer subtropical air masses, and by the latent heat released when moisture-laden air rises rapidly and condenses into cloud. Each of those energy inputs feeds the others in a feedback loop that can take a moderate system and turn it into something destructive in a matter of hours. The jet stream is the key driver of all of this, and understanding its current state helps explain why the UK is seeing storm after storm in a season that should be transitioning into spring. The jet stream is a ribbon of fast-moving air roughly 8 to 11 kilometers above the Earth's surface, blowing from west to east, and it acts as both a conveyor belt and an engine for Atlantic weather systems. When the jet stream is active and strongly amplified, it generates deep areas of low pressure over the Atlantic and steers them directly toward the British Isles. The speed of the jet stream determines how much energy is available to deepen those systems as they cross the ocean. In the weeks leading up to the current storm development, the jet stream was particularly energized by powerful storm systems over the eastern United States. As those systems intensified, they injected additional energy into the upper atmosphere, strengthening the downstream jet flow across the Atlantic. That energy is now arriving over the North Atlantic and pointing directly at the UK. The Met Office described the situation clearly in a recent deep dive. A sequence of Atlantic lows will cross the UK, bringing alternating spells of rain, showers, and strong winds, with the jet stream particularly active and pushing tightly packed isobars toward northern Scotland. Tightly packed isobars are not just a feature of a weather map. They are a direct visual representation of how fast the air at the surface is moving. The closer the isobars, the steeper the pressure gradient, the faster the wind. When forecasters see isobars compressing toward northern Scotland on the models, they are watching the signature of potentially very strong winds building in that region. And the current sequence of Atlantic lows is producing exactly that signature repeatedly through the late April period. Now here is what makes the next system particularly worth watching. The Met Office has confirmed that a new area of low pressure is approaching from the Atlantic by the end of this week, being strengthened by a strong jet stream driven by the contrast between cold air spilling south from Canada and much warmer air further south across the Atlantic. This contrast is the fuel for explosive deepening, and it is present in generous quantities in the current atmospheric setup. The system is currently expected to remain to the northwest of the UK, but will still bring unsettled conditions to Northern Ireland, Scotland, and western areas of Britain, with showers, spells of rain, and brisk winds. The Met Office has indicated it does not currently look comparable in strength to Storm Dave, but it has also been explicit that towards the middle of May, the weather patterns become increasingly uncertain, which is forecasting language that should be read carefully. It means the models are not fully agreeing on how deep the system will get and how closely it will track the UK. Systems that are still in the uncertain range of the models can and do intensify more than early guidance suggests, particularly when the jet stream energy inputs are as active as they currently are. There is an additional layer of context that makes this developing storm more significant than a typical late April weather system. The UK is coming out of a period of notably warm and dry weather that, while welcome, has left a very specific kind of vulnerability in the landscape. A stretch of high pressure through mid to late April brought temperatures up to 26 degrees Celsius in parts of the country, dry conditions across wide areas, and an extended period without significant rainfall across many regions. That dry period has not lasted long enough to constitute a serious drought, but it has left rivers running lower than average and soil moisture deficits building in some agricultural areas. When a frontal system carrying heavy rainfall arrives after a dry period, there is a brief window of heightened flood risk before the soil can absorb the incoming moisture, particularly across clay-heavy soils in the Midlands and East Anglia, and across areas where previous storm events have already saturated the ground at depth. The western uplands of Scotland, Wales, Cumbria, and the Pennines, which carry the combination of high rainfall accumulation and steep topography, are the zones that Environment Agency and CPA forecasters watch most closely when a heavy rain-bearing Atlantic system approaches. The combination of wind and rain in a rapidly deepening Atlantic system is what makes these events genuinely dangerous for the general public in ways that go beyond the obvious. High winds alone are disruptive. They knock down trees, damage roofs, disrupt rail and road travel, close bridges, and knock out power to thousands of homes. The UK's electricity distribution network, with its extensive overhead line infrastructure in rural areas, is particularly vulnerable to wind events above 60 miles per hour, which is why power cuts during major storms are almost always concentrated in rural and semi-rural communities where underground cabling has not yet been installed. The combination of wind with heavy rainfall, however, creates risks that are qualitatively different from either hazard alone. Wind-loosened trees fall more readily in saturated ground because the roots lose their grip in wet soil. Roads blocked by fallen trees during a storm are more dangerous to clear when conditions are simultaneously wet, dark, and gusty. And flash flooding that might develop gradually under steady rainfall can arrive much faster when intense frontal rain falls on ground that is already at or near saturation. For people planning travel during the approach and passage of this system, the practical implications are clear. Scotland, Northern Ireland, and northwest England are the areas where the most significant wind and rainfall impacts are expected in the current forecast. High-sided vehicles on exposed routes across the Cairngorms, the southern uplands of Scotland, the exposed coasts of Northern Ireland, and the northern Pennines should approach conditions with caution before any formal wind warnings are upgraded. The Met Office's new app features, rolled out ahead of Storm Dave, now include beach forecast information and water safety advice alongside standard weather warnings, which is relevant for anyone planning coastal activities during the tail end of the current dry spell before the front arrives. Coastal communities in western Scotland and along the exposed coasts of Northern Ireland are where storm surge risk is most concentrated when an Atlantic system deepens to the northwest and drives a sustained westerly to northwesterly fetch across the open ocean. The broader pattern for the coming weeks adds important context. The Met Office outlook through late April and into early May describes a generally more changeable or unsettled spell compared to the previous couple of weeks, with Atlantic low-pressure systems repeatedly approaching the UK. The wettest and windiest conditions are most likely in the northwest, with drier and more settled conditions in the southeast. Temperatures are expected to be near or slightly above normal overall. That overall pattern description, while moderate in tone, represents the atmospheric reality of what happens, when the jet stream becomes established in a strongly zonal west to east configuration across the North Atlantic. In a zonal pattern, storm tracks are consistent. Systems form off North America or over the western Atlantic, track eastward along the jet, and arrive at the British Isles in a repetitive conveyor sequence. The result is exactly what the UK is now experiencing. Not one dramatic storm that clears and is followed by settled weather, but a procession of systems arriving at regular intervals, each one giving the landscape and the infrastructure limited time to recover before the next one arrives. The science of why this pattern can produce more intense individual storms within the sequence is also worth understanding, because it challenges an intuitive assumption that more storms spread across a season must mean less severe individual events. The opposite can be true when the jet stream is energized by strong hemispheric temperature contrasts. Each individual storm in a zonal procession is drawing on the same energy source, the sharp temperature difference between cold polar air to the north and warmer subtropical air to the south. When that contrast is large and persistent, as it currently is given the late season Arctic cold air still present to the north and the early warmth that has been building in the mid-latitudes, individual systems that happen to develop in a particularly favorable position along the jet stream can deepen explosively and rapidly. Storm Dave demonstrated this on Easter weekend. The next system developing now may not reach Dave's intensity, but the atmospheric energy budget that produced Dave has not fundamentally changed. And the forecasting window within which the next system's full potential can be assessed is only now opening up. The National Center for Atmospheric Science, in its analysis of the 2025 to 2026 storm season, outlined the broader physical mechanism that underpins what the UK is experiencing. As human-caused climate change continues to warm the atmosphere, the air is able to hold more moisture. More moisture in the atmosphere means more condensation in developing clouds, which releases more energy, which in turn intensifies the storms that tap into that moisture. The practical consequence is that storms carrying heavy rain are expected to become more common, and storms with strong surface winds may cause more damage when they do occur. The most damaging UK storms are consistently those that intensify quickly, explosively deepening cyclones, and these are particularly sensitive to the availability of atmospheric moisture to fuel their development. Each major Atlantic storm that tracks toward the UK in 2026 is doing so in an atmosphere that is measurably more moisture-laden than the one that storms were developing in even 2 decades ago. That does not mean every storm will be record-breaking. What it means is that the upper end of what a given storm can achieve has shifted. A system that might have peaked at 80 miles per hour gusts in 2005 has more energy available to it in 2026. The probability that it exceeds 80 miles per hour, reaches 90, or develops faster than models initially suggested is higher now than it was in the baseline climate. This is the shift that makes early preparation more important than it has ever been, and that makes monitoring the Met Office's warning upgrades in the 48 to 72 hours. Before a developing system arrives, the single most important action anyone in a potentially affected area can take. Check the latest warnings on the Met Office website and app before the system arrives. If you are in Scotland, Northern Ireland, or Northwest England, treat any yellow wind warning as a cue to prepare, rather than to wait and see. Secure any items in your garden or on your property that could become projectiles in strong gusts. Know where your nearest Environment Agency or SEPA flood alert applies if you live near a river or in a coastal area. And keep your eye on the forecast updates over the next 24 to 48 hours, because this system is still in the phase where the models are refining their picture of how deep it will get and exactly where the strongest winds will track. That uncertainty is not a reason to relax. It is the reason to stay informed, because when an Atlantic low is deepening fast and the jet stream is active, the difference between an upgraded warning and no warning can close in a matter of hours. This next storm is intensifying, and the atmosphere over the North Atlantic right now is giving it exactly what it needs to keep doing so. The jet stream is energized, the temperature contrasts are sharp, the moisture content of the air streaming in from the west is high, and the recent procession of systems that has already included Storm Dave at 93 miles per hour at Capel Curig has established a pattern that shows no immediate sign of breaking down. The United Kingdom is in the active part of the Atlantic storm track. It will remain in it through the coming days, and the people living in its path deserve to know exactly what is building and why. Stay weather aware. Keep checking. The upgrades, when they come, will come fast.